The other day, a friend of mine told me she wanted to learn coding. She said, if I could make videos 5 minutes or shorter, she'd watch them. This is a valid comment to make about my channel, where videos routinely run 40 minutes or longer, and my idea of punk rock is explaining a concept in under 20 minutes. This series aims to teach the fundamental problem-solving approaches used in programming. Data structures and algorithms-themed questions are common in job interviews. To be honest, they're a little less common in game development, but they're still important. These concepts underpin a lot of the bedrock of computer science. To kick things off, you might have heard a lot of hubbub about the stack or the heap in programming. What are these things? Every time we create a local variable or call a function, some memory is allocated on the program's call stack. This is a quick and dirty way of passing data around, but it's limited. Have you ever heard of a stack overflow? This is what happens when a program tries to allocate too many local variables and runs out of stack space. Don't worry, a stack overflow isn't something mortals can cause. It's commonly caused by recursion, letting a function call itself. Recursion is the black art of computing. We'll look at that later. If we want to store information, lots of information, and we want that information to hang around long term, we give it some space on the heap. A heap is a topic we'll look at in a later video, but basically it's a balanced binary tree. It's large, really large, and even though it's optimized for random access, its size does make it a bit slower. Let's look at an example. A string is a set of characters. Each character takes up 1 byte of memory, so we can make a string of 100 characters without triggering a stack overflow. However, if we want to pass this string around to a bunch of different functions, then that's 100 bytes per pass, which is a lot of data going through our bus. To speed this up, we could pass a pointer to the string, but we have a problem. This string has been allocated on the stack, which means once the function ends, the string's lifespan will expire and the pointer will be useless, will be a dangling pointer. If we want to allocate memory on the heap, we call C's malloc memory allocate function. As an argument, we pass in the size in bytes that we're allocating. The program allocates the memory and returns a pointer to it. We can now use this string exactly the same way we used the first one, except this one will stick around when the party's over. The only other thing we need to remember is to free the memory. If we allocated it, then we have to free it. In Java, stack and heap concepts still exist under the hood. A lot more things in Java are heap allocated. Generally, only local variables are stacked. I hope you had fun, and I'll see you again soon.